Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps.com webinar. MultiCloud is here today and here to stay, brought to you by Red Hat Marketplace and Redis. We have a great webinar for you today, but before we get started, I need to go through some housekeeping announcements. Today's webinar is being recorded, so if you miss any part of the webinar, you will be able to access the recording for on-demand viewing. We will also be sending out a link to access the webinar on demand, or you can visit devops.com/webinars. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We also encourage discussion by using the chat tab, so let us know your thoughts or just say a quick hello. Also, if you look in the handout section, you'll see the slides for this presentation have been made available for you to download. Finally, stick around until the end because we are doing a drawing for 4 $25 Amazon gift cards, so stay tuned to see if you're a winner. And joining me today is Lars Rosenquist, Partner Solutions Architect at Redis. And with that, I'm going to put myself on mute, turn off my camera, and let you begin.
Hi, thanks for introducing me, Julio. So my name is Lars Rosenquist, and I'm a Partner Solution Architect at Redis. Before I worked at Redis, I joined Redis in February this year. Before I joined Redis, I worked for a company called Pivotal before it was acquired by VMware for the past 3 years or so. And before that, I spent around 17 years in developing enterprise software, typically in Java Enterprise, but also in a variety of other languages. As Julio said, in case you have any questions or remark, please use the chat and the Q&A sections present in this webinar. In case you have any questions after the webinar or you want to reach out, you can reach me on my email address, which is also in the slides that are handed out to you. You can also find me on Twitter and LinkedIn, so don't hesitate to reach out in case you have any questions. All right, with that, let's get started today, and I'll talk about how multi-cloud is here today and here to stay. Let's start off with a little bit of history lesson around the evolution of clouds and how multiple cloud types came to be. I don't know about a lot of you people, but I started my software development career all the way back in 1998. And the first time I developed software was on a mainframe. And that's typically, if we go back to around the late 70s or late 80s, that's really where enterprise application development started. So what we could see is that large enterprises, they typically had an on-premises data center. And in that on-premises data center, they had compute, storage, and network, which was provided by the mainframe. Typically, they also had an end-to-end service or two. Typically, it was a database like an IBM DB2 or an Oracle database or similar database types. Back in those days, the on-premises data center was a fairly simple affair, right? So there was mainframe. Back in the day, compute and storage network was still really expensive. So there was a bunch of dumb terminals connecting into the mainframe so that people could do their work. And this is really where automation of processes, business processes that were typically done on paper and using a lot of manual labor were being started to automate and being built in applications with really cool technology like COBOL and JCLs and that sort of technology. Of course, it didn't stay there, right? So as the 80s and the 90s progressed and more computing power became available and more services became available and application development went through a life cycle all the way up to the Millennium Bug migration, the Euro migration in Europe, and the dot-com bubble, we could see that these on-premises data center quickly started to evolve to become more complex. So instead of housing just a mainframe, services were added to house Linux servers or Windows servers or other types of servers. Different types of storages were being offered, but also different types of end-to-end services, not just databases, but also all kinds of other different types of services. What we also see is, as that typically evolved, it typically evolved in a way that all enterprise evolves, is the environments became a lot more complex, and that also means they became hard to manage. And as a result, because of all the bureaucracy that was built around these data centers, we could see that the developer experience was not too great. Of course, that all changed at the late 90s or early 2000s when we saw the dawn of public cloud. So what public cloud changed was taking these compute, storage, network, and end-to-end services and turning them into on-demand services and being able to rent them out to customers. That took place mostly in an automated way with transparent costs, well, mostly transparent costs. And it also meant that there was a great developer experience, or at least a lot better than traditionally on the on-premises data centers. Because now, as a developer, you can provision a service like a database and have it handed to you in minutes, rather than having to wait for several tickets for weeks or months, or waiting for hardware to be requested. Because in the end, a developer just wants a service, and they don't care about all the underlying storage and computer network that's required to run that service, right? So we could see that with the rise of companies like AWS, this became quickly very popular, and a very popular way to deploy applications and all kinds of other services. Of course, the vendors that were active in the on-premises data center space, they didn't sit still. And what we saw in the late 2000s, early 2010s, is the rise of the software-defined data center, right? So virtualization was really at the basis of both public and private cloud. It really made those things possible. So having virtualized compute, having virtualized storage, virtualized networking, and building end-to-end services on top of that. So what that did is basically give a lot better developer experience out of the box in an on-premises data center. Again, also mostly automated, and bringing some of the benefits of the public cloud into the on-premises world. Now, despite the growth of AWS and other public cloud companies, there was still a gigantic amount of workloads running on on-premise data centers, and that did not go unnoticed with them. So if we're looking at the late 2010s, so something of the past couple of years or so, we can see now that the public cloud providers are also back in extending the public cloud into the private data center by using technology like Google Anthos or AWS Outpost or Azure Arc, so that you can manage your on-premises resources with the same control planes that you can do in the public cloud. Of course, private cloud companies, companies like VMware or companies like IBM, and they saw the same thing, but with the public cloud. And in the end, they created software that also make it possible to manage public cloud resources using the same control planes as those are available in the public cloud or in the private cloud. Now, as you can see, the landscape of sort of where are my applications hosted and how am I building my services and how am I hosting my applications changed a lot. So there's a lot of choices to be made there. But that's not all. If we look at the middle of 2010s, 2015, about the rise of Kubernetes, we could see that there was a whole new paradigm in application development. And it meant that instead of having all kinds of different APIs in order to provision infrastructure and work with infrastructure, we could now see a common API in the Kubernetes API that allowed developers to provision resources from either a public or private cloud and deploy their applications using the same mechanisms. That's of course great, but it also meant a lot of complication. So just having, let's say, the choice of different clouds is one thing, but we can also see that cloud technology and or building your own platform for your developers became a lot more advanced over time as well. And that's illustrated by the use of the Cloud Native Computing Foundation Cloud Native Landscape. What it means that if you are building a platform for your developers to be able to run their applications on and also to consume service and build all types of services, you're going to have to go through each and every one of all these boxes and pick one or more technologies. You're also going to have to make sure those technologies can all work together. You have to install them. You have to make sure they're updated. You have to make sure they work together. Now, that's a lot of work. And especially if you are a bank, or if you are a retailer, or if you are a manufacturer, etc. Building cloud platforms is not your business. But if you want to provide your developers with the modern cloud native application development environments, you do want to do something with this, right? And if that's not the worst thing at all, this picture is not static, right? I mean, it's static on my screen because it's a picture, but in the end, this landscape continuously evolves in a rapid way, right? So Kubernetes is on a 4-month release schedule, and all these components, they get updates, new components come, older components go away, etc. It's a whole dynamic picture. As a matter of fact, the picture is so complex that there's even a map to be able to navigate this map. Now, as a company, you should always be asking yourself the question, sort of, should we do this? Is this our business? I would say if you are a company building platforms, so if you are Red Hat or IBM or VMware or Google, then yes, it makes sense to do this yourself. But if you're a bank or a retailer, you might be better off buying or consuming a platform from somebody whose actually business is building platforms. Now, this also becomes more complex. Let's say I want to do this across cloud providers, right? So I want to do this on my private cloud, but I also want to do it on a public cloud and maybe on another public cloud. And I also want these things communicating with each other. Now I don't have to make these decisions once, but I have to make them work across clouds, and I have to do them for each and every cloud individually, which, well, it can be quite a tough thing, and it can be a thing that will soak up a lot of money if you're going to do that all yourself. So the big question, of course, is when you see all this, why would I even want to do this? Why would I even want to use more than one cloud? Why would I go with a hybrid or a multi-cloud scenario in this case? Because it sounds like a lot of pain, right? Let's take a look. Let's take a look at multi-cloud, what it means. Let's take a look at the good, the bad, and the ugly. So let's start off with the good. If we look at some of the advantages that modern cloud brings, is that it allows you to get the best components out of each cloud. And each cloud has specific advantages and drawbacks. They're not all created equally. So some clouds are better at certain things than others. And that means that AWS is not Azure, and Azure is not GCP, and GCP is not Oracle Cloud. So these are all different, and they offer very specific services. So if you want to get the best services available to provide to your developers so they can build the applications that provide your business, you want to be able to use and mix and match the best services from the best clouds that are available. At the same time, don't discard your on-premises infrastructure just yet, because on-premises has advantages in many cases, right? So again, if we're talking about something like a manufacturer and you're running a production line and you've got robots working that production line, and these robots need to make decisions based on data that they're getting in and based on applications that are controlling these robots. Do you want those applications and data to be living in a cloud far away, or do you want them to live in a data center really close to your production line? I think the latter is more obvious in this case. But it can also be, let's say, critical infrastructure like a hospital. I mean, do you want to run that software in the cloud, or do you want to run it on premises on a data center inside the hospital, which is powered by a generator in case the power goes down? Right? So there are all kinds of reasons. And in financials, of course, we can also see the same thing happening with regulations, etc. Or if we're looking at, I don't know, systems of national security, I don't see them leaving their on-premises data center anytime soon for a large number of their applications. Another advantage is being able to spread availability and redundancy across more than one party. Personally, I don't think I've ever witnessed an entire cloud go down over the course of the years, but it is a good way for companies to at least have the option, right? And it's not just about the option of having this available in case of availability issues, but also as a way to have an exit path, right? So right now you really like your cloud provider, but what if in a year from now you don't? You want to be able to move your applications accordingly, and you don't want to spend 5 years on a cloud migration now and then spending another 5 years the next time you want to switch cloud providers, right? You want to minimize that time. What's also good is that if you're working with multiple cloud providers, you can lower your total cost of ownership by getting a better deal from each cloud provider. If a cloud provider will know that you are able to take your workloads off and move them somewhere else, that gives you a better position at the bargaining table, right? All right, let's take a look at some of the bad drawbacks. If you're going to deploy your applications across cloud and you're going to spread your data across cloud, you're looking at possibly a lot more complexity in your infrastructure and your application architecture, right? So remember that picture that I drew earlier where you have to make all those decisions? And this is really where modern application platforms or platform as a service or container platforms come in, because this is where they really help. Another drawback is latency, especially if you don't think about where you're going to place your applications and where you're going to place your data. So if you have applications living in one cloud and you have other applications living in your own data center or in another cloud, and they need to communicate with each other or they need to fetch data, you need to be sure that that can happen in a fast way. And that is one of the drawbacks when dealing with multi-cloud. But this is really where data platforms and something like Redis Enterprise can help. And I'll explain that how that works a little bit further on in this presentation. Interesting. I just said you could lower TCO, and I said it was an advantage of the cloud, but now I'm saying you have increased TCO. Yep. So if you're not careful and you're going to duplicate things, and you're going to have to duplicate things when you're using more than one cloud. So for instance, if you're building out your applications on Google and on your internal data center, and you need to have deployment pipelines, etc. So what technology are you going to pick there? If you're not careful, you're going to end up duplicating a lot of stuff, which means that, yeah, you're burning lots of money where you don't really need to. There are also hidden costs, like egress costs, and I'll explain in a little bit what that means exactly. But in short, what it means is that whenever you have network traffic going out of your cloud or going out of your region or going out of your availability zone, you're going to pay an additional fee on top of your regular network costs. And that can make it very expensive if you're not very careful in your application architecture and in your data architecture. Now we talked about the good and the bad. Let's talk about the ugly, and let's talk about necessity. I've worked for a lot of companies back in the day, and I've worked for a lot of enterprises. And in some of those enterprises, we simply, as a development team, because we had increasing demands from our stakeholders or our deadlines that we needed to meet, and our internal infrastructure folks were not able to meet those demands with the platform and the processes they had in place, we simply moved to the public cloud, regardless of whether that was allowed or not, right? So we made sure we got a mandate from a CIO or a VP, etc., and then we simply moved our applications into the public cloud. So if you're an organization that's sufficiently large enough today, you might already be a multi-cloud or a hybrid cloud party without even knowing it, because some of your developers may have already been making the move to the cloud. That's not all. If you're currently in a cloud migration, and that's a thing that's been popular for a number of years now, right? And it's been accelerated by COVID. Digital transformation processes are going on all over the world, all over Europe, all over the US and APAC and all those other regions. A cloud migration, even if you're planning to move all your applications from your on-premise data center into the public cloud, it's not going to be a big bang scenario, right? So you're going to take probably multiple years in order to move all your applications from one place to the other, or maybe it's months if you can do it quickly. But in any case, you're going to end up in a hybrid scenario anyway. Some of your applications are going to be migrated already, and some of your applications are not. So does it mean you're already in a hybrid scenario? Yeah, pretty much. And it pretty much means that you're going to have to think about how this is going to play together and how this is going to work together without your applications crumbling on, a number of those drawbacks that I already mentioned. So speaking about cloud migration, cloud migration is really a thing for companies that have something to migrate, right? So it's companies that have been around a while. They have an existing estate on a private data center, and they want to make the move into the cloud, and they want to use modern application platforms such as Kubernetes, and they want to deploy applications there. And becoming a cloud native is not easy. I mean, it's easy if you started your company in the past 2 years and you started deploying all your stuff on Kubernetes straight away and you don't have legacy. Yeah, then it's really easy. But in case you have existing processes and existing bureaucracy, it's going to be very, very hard. So some of those things that you need to understand when you're starting on a cloud migration. So first thing, one of the most important things is that infrastructure folks or infrastructure departments that are looking to build out a platform as a service for developers, they need to understand their customers. And when I say customers, I mean developers, right? Because in the end, infrastructure is a means to an end. It's a means to run applications. And applications are also a means to an end because they're a means to generate more business value, right? And you have to understand your customer base, but you also need to understand what they need. And that's not necessarily what they want, right? Because if you ask a developer what they want, they will say Kubernetes or AI or blockchain or whatever. But what they really need is that, super highway into production, so that whenever they want to provision something or they want to build an application and want to push it in production, you can do it in a way that's fully automated, but also at the same time fully secured and fully compliant. You also need to understand that the cloud migration is not just a technical thing. So we always talk about cloud migration, sort of moving applications from A to B. But if you want to really become a cloud native organization, you also need to understand that a cloud migration is also a reorganization, right? You can buy or consume all the technology in the world and deploy that in your own data center or use the public cloud or whatever. But if you continue to manage those resources in the same way that you've been doing for ages in your private data center with the same amount of bureaucracy and the same amount of processing behind that, your cloud migration is most likely going to stall. Again, I'll talk about understanding that a cloud migration is a hybrid cloud by definition, right? So You can sort of think that you're going to migrate to a single cloud platform, but at the same time, you're going to end up in a hybrid cloud pretty much by default anyway. So it's better to think about that in advance than doing that on the spot when you're confronted with problems. Number 4, which is also very important when you're dealing with cloud migration, is that you need to understand that a platform is to be treated as a product. It's not some project that you do for 6 months and then it's done. No, it's a project. And as we could see that it's an ecosystem that's evolving and it's evolving rapidly, it also means that the needs of your developers are changing all the time. I mean, we can see that already over the past couple of years when COVID hit, right? So when COVID hit in 2020 and there were lockdowns all throughout Europe, it means that companies needed to be able to think on the top of their feet and spin around really, really quickly, because they needed to deal with a situation where customers were no longer allowed to be on site, but they still needed to do something like ordering or curbside pickup or whatever. And they needed to, be able to think on their feet. You can do that if you treat your platform as a product, and it means you need to give it a project manager or a product manager, sorry. Yeah, you need to assign it a backlog. It needs to have engineers, and it needs to have a budget, right? A continuous budget, not some finite project budget. If you can do that, then you can have a platform and build it out and be successful about it. 5th important thing to understand is that applications and data go hand in hand. In some cases, that's being referred to as data gravity, but I like to refer to it as latency gravity. In short, it means that if there's an application and it's operating on data, that application likes to be close to the data, because it means the latency is low, and it means that data can be processed in a way that's extremely quick and is extremely efficient. And we can see that. So applications clutter around the data, and then, of course, applications also clutter around other applications. If you fail to recognize this, you can end up in a situation where maybe you're moving an application into the public cloud while your data is still firmly on premises. That can cause a lot of differences. I mean, egress costs may say hi again, but also latency is also not something that is to be underestimated in these cases, right? So something to be understood. Last but not least, you need to understand that the cloud-native landscape, the picture that I showed you earlier, is extremely fluid. It's not a static picture. It's something that's keeping moving all the time, and it's in motion all the time. And also, your migration is going to take years, if not, and it can be 1 or 2 years, or maybe it can be 4 or 5 years, depending on how old and how complex your application landscape is. So how are you going to deal with those changes? And we'll talk a lot about that a little bit more in the rest of the presentation. So how can you bridge the gap? How can we bridge the gap between public cloud on one side and private cloud on the other side, or public cloud on one side and another public cloud on the other side? That's pretty much works in similar ways. I won't be talking about all the organizational aspects of being in a cloud migration. I mean, that could be a whole separate webinar just to talk about that, so I'm not going to do that today. Instead, I will talk about application platforms and data platforms, and how they can be used to bridge the gap between clouds and make life easier for your developers. So what is a unified application platform? A unified application platform is really a way to provide a single experience for your developers and a single experience for your operators, regardless of which cloud your applications are going to be deployed on. So the first thing that it should do is to provide a seamless experience for your developers. So no duplication of APIs, no duplication of pipelines, etc. What that really means is that your developers should be able to write a single set of pipelines, use a single API, like the Kubernetes API, or let's say OpenShift API, or the Tanzu API, or the Cloud Foundry API, be able to deploy applications, provision resources that they need, or dependent services, and then be done with that. And if they're going to deploy on a different cloud, it should be just a matter of switching an endpoint in the configuration and not writing a whole new pipeline. At the same time, your operations wants to stay in control. And again, having a single management API, either through Kubernetes or other means, helps with that a lot. So it means you can stay fully in control in a fully automated way while giving freedom to your developers. At the same time, a platform should encapsulate the complexity of the cloud-native landscape. And again, if your business is not selling platforms, you should probably not be building this yourself. You should probably buy a platform from a vendor or consume a platform from a managed service provider. So don't build it yourself unless you can monetize it. I mean, if you have a platform and you have users for it and you can monetize that, then by all means go and build your own platform. And even then, I would recommend, let's say, leveraging all the combined engineering efforts of some of the vendors that are out there providing products in this space. So how does that look? And I'm going to use, in this case, I'm going to use OpenShift as an example because it's a platform I really like, but I'm not limited to those platforms. I'm just using it as an example. So when you're in your private cloud and you can deploy OpenShift there, so you can deploy it on virtual machines or on bare metal, that's all up to you. And OpenShift will provide a way to interact with the platform. There's a Kubernetes API, they've got an OpenShift API, they've got a web console. And that means that your developers and your operators can write pipelines and they can write automation around that in order for your operators to manage the platform, manage platform updates, etc. And for your developers to deploy applications and to deploy, depending services that they need. Now, if I'm going to add public cloud in that sense, and I'm also going to deploy an OpenShift there, for my developers, pretty much everything stays the same. It means that they have their pipelines and all they have to do is change their configuration and they can deploy those applications, well, on the public cloud or the private cloud, whatever, doesn't matter. Now that's great. And like I said, I mean, I'm using OpenShift in this example, but I mean, if we go to the competition and we go to VMware with Tanzu, they'll have a similar setup, though they will, of course, work differently. And you can go to SUSE and they will have something like Rancher. And there's a whole bunch of other providers out there and that are building products around that, but I didn't have space on the slide to fit all the logos. So I'll just keep it at these three examples. Doesn't mean I have a specific preference for any of these three, by the way. Now that's from the application side. So let's take a look what you want to do from the data side of things. So on the data side of things, we're going to do pretty much the same thing or apply pretty much the same patterns, right? We want to provide a single experience for both developers and a single experience for people who are operating the platform. What we're really seeing happening right now, and this is also where Redis Enterprise is playing a large part, is the reimagining of the general purpose database, or these days it's being called the multimodal database. So why is that a reimagining? So if we go all the way back again to the mainframe, we could see that relational databases were pretty much king, right? It all started with the DB2s and the Oracles of these world. At the late of 90s, at the end of the 90s, we saw NoSQL solutions becoming really popular. And one of the properties of most NoSQL solutions is that they were not general purpose. They were actually single purpose. So they solve a single problem. So an example of this, if you look at a time series database, it solves a single problem. If you look at a graph database, it solves a single problem. If you look at a white column database, it solves a single problem. If you look at a key value store, it solves one specific problem. What we saw back then was kind of a split, but what we see today is that these worlds are really converging. So we can see that on two sides. On one side, we see modern relational databases moving into the cloud, being able to become distributed, sharded, etc., being able to provide that consistency at scale. At the same time, we also see a lot of NoSQL solutions expanding their models and expanding their feature list to make sure that they can reach a broad audience. Whatever solution you pick, there's one thing that's going to be important, and that is the necessity for real-time and in-memory data platforms. And the reason for that is because it's not, let's say, 20 years ago. I mean, 20 years ago, you would have a user using an application, they would fill out some form, and then a request was sent to a server, and then the server sends a request to a dozen other servers, and then aggregates the information and processes it, and forwards the response back to the client or the end user, and the end user takes that response and then does something with it. But that's not how it works today. Today in Netherlands, the shops are closed. I can do a store pickup, but that also means that if I'm going to order something at a store, let's say it's a do-it-yourself store, because that's what people do when they're locked down. They fix their houses, right? I mean, I don't know how it is in the rest of the world, but that's what they do in the Netherlands. So it's going to be really busy. So when I go out, I want to make only one trip. I don't want to make 10 trips to 10 different stores. I want to make one trip to the store, and I want to go pick up my stuff. So I want to see when I am selecting product and putting it in my basket, I want to see those products, and I want to see how it is with the local stock. I want to know that the stuff that I want to order is actually there. And when somebody orders the last item that I also have in my shop list, I don't want to find out at the end of the process when I'm ordering. I want to see that straight away. Same thing for financial applications. If there is an update in my financial status or amounts are coming into my bank, or whatever, stock updates, etc. I want those things to happen in real time. We don't want to wait around for those. So you need data platforms that are able to support that kind of real-time interaction. Again, what's important here is to create a single control plane and an API across clouds so that you can deploy an application or that uses these data platforms across clouds, and they don't have to change anything, maybe a little bit of configuration in the form of an endpoint URL, but that's pretty much it. For data platforms, if we compare it to, let's say, the story compared to application platforms, there's one thing different, and that is that the data platform will contain data. And for that reason, it is important that a data platform is able to synchronize data across clouds and doing that in an active way. So allowing both reads and writes on both sides of the fence. And we'll get to that in a minute, why that is important. It also means that you can keep your data local to your applications. So I have applications running in my public cloud in region, I don't know, US East 1, for instance. It means that my application is running in the same region as where my data is, which means I don't have to go outside of my region, which means I don't get egress costs. It also means that the latency from my application towards my data platform is the lowest that I can get, which is also a great reason. Do I always want to stay local? No, US East 1 might go down. And in that case, I want to branch out or reach out to another region or another cloud in that case, so I can keep my store open. So again, if we draw that picture and we take a look at private cloud, you can deploy something like Redis Enterprise, which is a real-time in-memory data platform based on Redis. And again, pretty much like OpenShift has APIs, Redis Enterprise also has APIs. So it has a Redis API for application developers to be able to interact with and do all kinds of things with data. But it also has a Kubernetes API, so you can provision database and stuff like that. So it's something that typically operators would use. There's also a REST API, again, typically used for administration, and there's an admin console as well for people who would like to use an API. Pretty much like a modern application platform, you can see that developers and operators can write pipelines for a platform only once, and when you deploy that application onto the public cloud, they can use the same pipelines and use the same mechanisms that they are already used to using. Right? So it totally makes sense. So for both application and data, to make sure that your platforms are consistent across clouds, and it makes facilitating migrations a lot easier because you only have to migrate your platform or add an additional platform rather than having to restructure your entire application. Of course, that's not all. Active replication, and in case of Redis Enterprise, that's working with a concept called CRDTs, which stands for conflict-free resolution data types, which means that whenever there's an update on one side of the fence, that update will be automatically processed and propagated to the other side of the fence, which is great, right? This not only helps to minimize latency, but it also helps to minimize your egress costs. Because if you're running a microservice architecture and you've got applications that are all scattered across both clouds, you don't want those applications to ping pong between clouds, because every time you send a request from one cloud to the other, you're going to pay with egress costs, right? So this is something that a modern real-time data platform like Redis Enterprise can help minimize, because it only synchronizes on the updates, and then the application can stay local and retrieve the data or update the data. It doesn't have to cross the line in order to do that. And that's a very powerful concept in a multi-cloud, in a hybrid cloud solution setup. So how do we bring all of these things together? So let's take a look at that. Oh, there's one more thing. Redis used to be a cache. It used to be primarily used as a key value store, but having a multimodal means that you can extend it through the use of modules. So that means you can add additional data types like time series or graphs or JSON, but you can also add additional capabilities like search or being able to run code inside your database using gears, or being able to use machine learning and AI, or being able to use a Bloom filter. It's a very powerful way of dealing with your data. And again, it means that by extending your existing platform with capabilities like this, your developers can keep reusing the mechanisms that they're already using and simply add new functionality in that using the same or similar APIs. All right, so how do we glue it all together? Because that's also possible, right? So again, we've got a public cloud and a private cloud. In the end, I've labeled this one private cloud, but it can also be another public cloud, right? There's no limitation on that in that sense. And We've got a modern platform as a service, such as OpenShift, but again, it can also be VMware Tanzu or Rancher or whatever your favorite application platform is. And then we can deploy a modern real-time data platform using the Kubernetes operator. So Redis Enterprise has a Kubernetes operator that's available through the Red Hat Marketplace. And then you can deploy Redis Enterprise on top of OpenShift. So running a stateful application data platform on top of Kubernetes. Yes, that's a thing these days. That's totally possible. Of course, applications will also be running on top of your favorite Kubernetes platform. And those applications will also be using your real-time data platform in their location of choice, right? In their closest location, if possible. And again, data is being synchronized between the two clouds to make sure that both applications see the same thing on the same side. But that's not all what databases or applications do, right? Some applications might still be connected to a legacy database. Some of them might not even be deployed on a modern application platform. Maybe they're still deployed on virtual machines or on bare metal, for instance. And these are applications, I've seen those applications. I've talked to a lot of banks in the past, and they have applications sitting in the basement that are over 50 years old. And they've had 50 years worth of history of maintenance, 50 years worth of reorgs. There's no documentation, no testing, etc. So how are you going to bring these applications in the modern age? And of course, modern databases, it's not really a problem, because modern databases, you can either deploy them on virtual machines or you can deploy them on containers in the cloud, right? You can deploy Postgres on Kubernetes. That's perfectly possible these days. But for these legacy applications, you still want to have kind of a mechanism, right? These applications are really hard to migrate. At the same time, you really want to make sure that you can still build extensions, right? And this is where mechanisms like change data capture come in, right? So using change data capture, you can synchronize the contents of your legacy relational database and then use a tool like Redis Connect, which is included with Redis Enterprise, or you can use an open source solution like Debezium to synchronize those changes and bring them into the modern world. So you can take all the data that's in your legacy database and then synchronize that to a modern platform like Redis Enterprise, or maybe do it via event-driven architecture using Apache Kafka or leveraging all kinds of other technologies. And you can bring that in the modern world. So it means you can keep your legacy application and its legacy database firmly entrenched in your private data center where it is and where it's working, and I'm assuming it's making money for you, while at the same time being able to build extensions using that same data on a more modern platform, and being able to, well, maybe you should start building out testing frameworks or other types of solutions in order to help facilitate the migration of those old applications. All right. So I guess everything is great then, right? So we just deploy an application platform, deploy a data platform, and then we're done, right? We're in cloud nirvana and everything will work accordingly, right? It's easy thing to do, right? Just install these things and it's done. That's not really the whole story, right? So as always, there are no silver bullets in any case, whether it's platforms or application frameworks or any other tooling you're using, there are never silver bullets. There's always advantages and drawbacks. So let's take a look at some of the common pitfalls that come into play when dealing with cloud migration or when dealing with multi or hybrid cloud. So some of the common pitfalls that we see happening and that I've seen happening over the course of my career and dealing with customers is one of the most common pitfalls that we see is that organizations are not really changing their organization to meet demands of the customers, in this case, developers, right? So they think it's just a technical migration and they think they can just buy some technology, deploy it in the data center, and then be done with it. No, the reality is you need to change your organization and your way of working in order to be able to support these multi-cloud platforms and make them work. Planning a single cloud strategy when in reality you will end up in a hybrid setup at the minimum. And this is something that we see also that's very common. So customers have the idea that, we're going to migrate all our workloads to Cloud X, when in reality they will end up in a hybrid situation at the minimum and possibly in a multi-cloud scenario in the future. So if you're going to end up there anyway, you might as well start planning for it straight away and start thinking about how that's going to work straight away, rather than doing that in the heat of moment when you're being confronted with problems. Number 3, not having a data migration strategy along with your application migration strategy. So think about what type of data you have and how you want to expose that. Think about where you want to have real-time data capabilities. Think about where you want to have your time series and your graphs and all those other types of databases, and think about how you want to do that and how you want to distribute that across your clouds. Think about that in advance. You can also delegate that to all your development teams. Then they will each and every single one of them figure out a solution of their own. And in the end, you're also not going to be happy because it's going to cause you a lot of pain and a lot of overhead issues. Number 4, thinking that you can migrate absolutely everything. This is also something that is, in a lot of cases, it's not true. I mentioned these applications that are very old with a very large history. Yeah, sometimes it's just not worth migrating something. As a matter of fact, there's probably a lot of applications in your departments that should not be migrated because they add no business value, right? So turning off applications is definitely also an alternative, right? So make sure that you think about that when you're setting up your application migration strategy, right? Be sure to categorize those applications in the categories where you're going to say, hey, these applications we're going to turn off. These applications we can migrate as is, and these applications we're going to modernize, right? So, of course, turning off applications, that can have implications, right? Because applications are typically used by people, maybe internally. So maybe there's a department that's using this application, which essentially, if you're saying that the application doesn't have value, maybe this department is also something that might need to be closed out or something like that, which can get you in really difficult conversations. So I'm definitely not saying it's an easy thing, but it's definitely something that we see popping up. Another thing that we're seeing is customers building their own platforms instead of buying and consuming. And typically how this will start, it will start very small. So customers will build their own Kubernetes cluster, and they'll start out with a small, simple cluster and a small, simple Hello World application. And that, of course, works, right? You can build that with one person, build a platform with one person, build an application with one person, and hey, it's all working perfectly. Yes, that's because it's only one cluster and only one application. But then comes along a slightly more difficult application and another one. And as the platform becomes more successful, it becomes to grow. But you didn't anticipate on building your own platform. So now all of a sudden you don't have engineers to manage that. And the cloud native landscape is fluid, so it's changing all the time. So you end up missing updates, etc. And Kubernetes is on a 4-month update cycle. So again, you can quickly see these platforms spinning out of control as they become more successful, and in the end, they grow over the company's heads, because in the end, they should not be building platforms. They should be building applications that bring value to their business. So if you're going to end up, again, I've seen quite a few cases of this where customers started out doing this. It quickly grew over their heads. Their platform failed, and then they went through to a vendor to either consume something or to buy something. So why not do that straight away? Saves you a lot of money. Spend that money in building out an actual platform as a service using the stuff that you bought or consuming. Last but not least, not redesigning your applications and data to be cloud native. You can't just port your applications from your private data center, especially if it's not cloud native, and then just dump it onto Kubernetes and thinking it works. Especially if your applications have state in them, or if your applications, I don't know, maybe they don't like restarts, or maybe they take a long time to start. This is typically something where just moving an application is going to cause a lot of pain. So you're better off either keeping it where it is, or you need to spend the effort and time in redesigning those applications to be cloud native. Think about 12-factor applications. Maybe you don't need all the 12 factors. Maybe you need only a handful of them. But think about these things and think about what you want to do with these applications, because you can't just take a non-cloud native application and deploy it on a Kubernetes cluster. Last but not least, and I realize I'm saying that twice, underestimating hidden costs, right? So we talked about, let's say, the amount of costs that can be involved in building out your own platform, but things like egress costs, right? Yes, it's technically possible to just take a Kubernetes installation or multiple Kubernetes installations and bridge them across all the clouds, put a service mesh on top of that, deploy your application in there, and let the whole thing figure out by itself where it needs to route or not. If you don't take care, the egress costs are going to be a very nasty surprise in your cloud build, right? And it can increase even more if you go to a multi-cloud scenario, right? Because then you have multiple cloud providers involved, and that might include double costs. All right, to summarize a little bit. All right, single cloud is hard. but multi and hybrid cloud are significantly harder. So you need to plan in advance in order to make the most out of them. Make sure you have a multi-cloud strategy, because you are going to end up there anyway, regardless of whether you intend it or not. Applications and data go hand in hand. Latency gravity is a thing, so be sure to take that into account when you're designing your application and infrastructure architectures. Developers have a way of choosing the path of least resistance. So unless you are able to become that highway to production and provide value for them, they will go somewhere else, whether you want to or not, because developers are under a lot of pressure in order to deliver a lot more value with less and less resources, right? So you really want to become that highway into production for your developers in order to provide the features that they need. And again, I'm reiterating this, but don't build your own do-it-yourself platforms unless you have a way to monetize them. So unless you are a provider of managed Kubernetes platforms or managed platform as a service, I would not advise you to build your own platform. And even if you are a company that's building out a managed service, be smart and reuse all the engineering capabilities of great companies like Google, IBM, Red Hat, VMware, Redis, and all those companies out there. All right. I also have some additional reading material available in the form of a number of things. So you can read all about 12-factor applications and the upside-down economics of do-it-yourself platforms. And you can also read about reinventing your data layer with Redis and how you can do a multi-cloud with OpenShift in the links that are provided. The presentation is provided in the handouts, so you can just download the handout and you can click on the links. There's no need for you to write them down. And that is pretty much all I had to say for today. So let's take a look at the Q&A to see if there are questions, Julio.
Yes, we do have a few questions, but just as a reminder that if you do have a question, you can head on over to the Q&A tab and to submit your question there. Okay, first question. Would you recommend using cloud providers' automation and CI/CD mechanisms, or would you use an abstraction for these as well?
Yeah, so that's a really good question. That's a really good question, Julio. So I'll answer that. And if we look at most cloud providers will have available great services for automation around CI/CD, and they work well. However, there's a risk in multi-cloud scenarios. So if you end up investing in something like Azure DevOps and you want to get rid of Azure at some point in time and you want to go to AWS or GCP, or maybe you want to go back into your own data center, that's also possible, however. So that means you might end up duplicating logic. Of course, you don't have to. You can use something like Azure DevOps together with AWS, for instance. That's perfectly fine. But again, you're looking at things like egress costs that might make it a very expensive thing to run. Alternatively, you could use technology like Terraform and Ansible, which are mostly cloud agnostic, and even deploying something like Jenkins could be portable across clouds.
Excellent. Second question: does Kubernetes provide an abstraction over everything the cloud provider offers?
Yeah, that's a good question. So the short answer there is no, it does not. So it does provide a Kubernetes API for a couple of generic services, like being able to provision infrastructure and load balancers, etc. But even the generic ones, like load balancers, they may have specific properties that you need to set and configure in order to tweak them to the most. Is it really a problem? For a lot of applications, you don't need to do that. So it's not a problem at all. But in many cases, in some cases, you might need to tweak those specific services. And again, if you have really specific cloud services like location services or specific services from a cloud provider, they're not going to be available in Kubernetes, but they don't need to be, right? So in the end, I would always recommend customers don't worry too much about edge cases. If you have a platform that can handle 90% of your workloads, you're in a pretty good shape. And for those specialized applications, you will have specialized solutions. And that's perfectly fine. It's perfectly fine to not deploy every application that you have onto a Kubernetes platform. It's perfectly fine to have some applications that you're deploying in a specialized way. It's really okay, right?
Okay, just got a question in. From the companies that you work with, where do you think we are overall in the cloud mitigation process? 50% there?
I see a lot of varying results there. I see companies that have made the migration for as much as 90%. And these are enterprises, right? So Dutch banks I've worked with are very far ahead in this cloud migration. But I've also talked to a bank earlier this year who were just starting out on it. So I think 50% is an average. But it can vary a lot, and it can also vary a lot with the size of the company. So I think a lot, let's say in the Netherlands, what we consider a large bank is, on the grand scheme of things, is a fairly small bank, so they can move a lot quicker. But if you look at those really big companies like you have in the United States, or that we have in Switzerland or in the UK, I think they're less further ahead than we want to think.
Another question here. What is your opinion of the need for cross-cloud CASB products like Netscope?
I have to say that's not really my area of expertise, so I'm sorry I cannot answer that question, but I will follow up with the answer on that one.
And and the last question for now that I see is, do modern application platforms solve all multi-hybrid cloud challenges?
Well, as always, there are no silver bullets or golden hammers, and I said it earlier. So if you are a sufficiently large application or a sufficiently large organization, you're always going to have some edge cases or applications that do not fit. I would just really would like to recommend that you don't throw out a solution that fits 95% of your use cases because it doesn't fit 1 or 2%. Right? It's fine to have specialized solutions for a bunch of specialized applications.
Okay. New question just came in. With multi-clouds, how does the change? I'm sorry. With multi-clouds, how does this change the security frameworks that are needed?
Yeah, so if you look at security, that's typically one of those things that can get very complicated when you're dealing with a multi-cloud cloud solution. So let's take a look at, if I limit the question to application platforms or to container platforms, and those platforms that operate in a cloud native way. What's really important there is that, so for one is being able to have those secure container images, right? So you want to have an automated solution in order to patch your container images and to make sure that you can respond on CVEs directly. So if that has to go through a manual process every single time, that means that you will limit your ability to be able to respond to, let's say 0 days. I mean, the Log4j example is a pretty good thing. Most applications will be just fine if you just update the library, run a few basic tests, and then deploy it into production. There's no need to do anything special. Maybe a couple of specific cases are going to require more, but you want to be able to do those things quickly. There are platforms out there that allow you to do that. So I know that the folks from VMware are doing pretty cool things with something like Tanzu Build Service that can allow you to do that. But in the end, if we look at security frameworks like existing security frameworks, you need to be able to bridge that out into the cloud, all right? So if we're thinking about, maybe you're running, let's say, Active Directory on premise, and you want to make sure that that is also being synchronized with Active Directory that you're running in Azure. Yes, you need to do things in order to make that work, right? It doesn't come out of the box. You have to wire those things together.
Excellent. I don't see any more questions, but we do have a little bit of time. So in the meantime, I'll go ahead and announce the 4 Amazon gift card winners. Our first winner today is Andrew L. Congratulations. Our second winner is James R. Our third winner is Julie H. And our final winner is Kyle M. So congratulations to all our winners. We'll be reaching out to you via email with instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, check your spam folder. So I'm not seeing any more questions. So we'll do a last call for those if you have anything. So going once. Going twice. All right, then. Well, for now, I will remind everybody that today's webinar has been recorded. So if you missed any or all of the webinar, you will be able to watch it again. We will be sending an email with a link to access the webinar on demand. And you can also find the webinar on devops.com. Just look in the on-demand section in the webinars page, and you will see it there. Lars, thank you very much for taking the time to put this presentation together and for giving us an hour of your time. very informative. We all appreciate it, and the chat certainly appreciates it as well.
Thanks for having me and providing me with the opportunity.
Excellent. Thanks again to the audience for their time and engagement, as well as Red Hat Marketplace for sponsoring this event. This is Julio Godinez, signing off until next time. Take care and have a happy holidays. Thank you.
Bye-bye.